Hey everyone. So this one is called Relating F with F prime and F double prime. This is assignment 63 homework worksheet relating, I kind of want to retitle this, Relating F with F prime and F double prime. I kind of want to call it that. Relating F prime with F and F double prime, but we're going to go with as it's typed. Okay, so here we're asked to consider the sign of the first and second derivatives in each case. In problem number 1, I'm looking at something like this for f of x. So f prime is greater than 0 and f double prime is greater than 0. How do I know that? Well, I see f is increasing, so f prime must be positive, and I see f is concave up, which means f double prime must be positive. Okay? All right. So, 2. That's 1. What about 2? 2's graph looks like this. Well, if I take the derivative of that horizontal line, f prime is going to be 0. And when I take the derivative of 0, f double prime is also 0. So, yeah, I don't have signs so much as zeros for number 2. 3. I'm looking at this function. This function, f prime is less than 0 because this function is decreasing and therefore has negative slope everywhere, so f prime must be negative. But f double prime, if I take the derivative of the derivative, yeah, I'm getting 0. Think about it. I mean, if I take the derivative of this negative 2x plus 5 kind of thing, the derivative is going to be negative 2. And if I take the derivative of f prime equals negative 2, the derivative of the constant is 0. Okay, what about problem 4? 4 looks like this. Okay, so what do I see? I see decreasing, so f prime is less than 0. I see concave up, so f double prime is greater than 0, which means that f prime is negative and f double prime is positive. Okay, yeah, I'm supposed to be saying positive or negative. This is positive, positive. Nice. And here, f prime is negative. Okay, problem 5. Problem 5 looks like this. And so I say with problem 5, f prime is positive because this function is increasing, but f double prime is negative because this function is concave down. And finally, if I look at number 6, which looks like this, I see my function is decreasing, so f prime is negative, and my function is concave down, so f double prime is also negative. So there's number 6. Number 8, let P of t represent the price of a share of stock as a function of time. What do the following statements tell us about the signs of the first and second derivatives of P? Okay, for part A, we're told the stock price is rising faster and faster. So the price is rising, so we know we have an increasing function, but the stock price is rising faster and faster. Faster and faster, I got that concave up. I got positive slopes because price is rising. But price is rising faster and faster, which means that these slopes are getting more and more positive. So to answer the question they ask us, what do we know about the signs of the first and second derivative? P prime is positive, the stock price is going up. P double prime is positive, the stock price is going up faster and faster. Okay, what about B? The price of the stock is close to bottoming out. Wow. That's bottoming out. And so in part B, I would say P prime is definitely negative because bottoming out means, yeah, we're going to just not have any stock price anymore soon. So this function must be decreasing. However, because I'm getting closer and closer to bottoming out, P double prime is positive. That means the price drops really fast, and then the price drops slower and slower. Still dropping, but slower and slower. This is the price is dropping faster and faster. We're close to getting to our lowest price. Okay, 9. Winning the war on poverty. Uh, I was a child, there was a large national conversation about fighting poverty. Um, and here it says winning the war on poverty has been described cynically as slowing the rate at which people slip below the poverty line. So here's a poverty line, and the people, which is slowing the rate at which people are slipping below the poverty line. And so in this situation, yeah, no, I'm not comfortable with this yet. I want to read this question some more. Assuming that this is happening, sketch a graph of the total number of people in poverty against time. Well, I think I'm looking at this. Why am I looking at this? Because what's implied here is that more and more and more people are going into poverty. And all we're doing is slowing the rate at which they go into poverty. So do something like that. This is our poverty line. Yeah. And so I think what I can say here is if n is the number of people below the poverty line at time equal to t, what are the signs of the first and second derivative? Yeah, I think that more and more people are, this is it. This is n, the number of people in poverty. And this is some sort of logistic curve. And here, this is all the people. And so, more and more people are going into poverty, but the rate at which they're going into poverty, i.e. the slope here, is getting smaller and smaller. We're slowing the rate at which people go into poverty. So what can I say about the signs of the first and second derivative? Well, I can say that n prime would be positive and n double prime would be negative. This is the part about slowing the rate. I'm slowing this rate. This is telling me that more and more people are going into poverty. This tells me that the rate at which people are going into poverty is slowing down. And that's great. It's great that fewer and fewer, but I think the presumption is that most people have already, and so there are fewer and fewer people left to join us. Oh, that's a grim question. Okay, 18. An economist is interested in how the price of a certain commodity affects sales. Suppose that the price $ is P for quantity Q. Q is quantity. And we've got F of P. We plug in a price. We plug in a price and we get out a quantity. Explain in economic terms the meaning of the statements F of 10 equals 240,000 and F prime of 10 equals negative 29,000. Okay, so first this one. Input was price. When price is $10, we have 240,000 of these mysterious commodities sold. We can sell 240,000 of them when the price is 10. That's what this says. When the price is 10, we'll sell 240,000. But this one says, when the price is 10, the change in the number sold is this. We sell 29,000 fewer for every $1 increase in price. And I imagine that most of you are saying, what the hell is he talking about there? Well, let's think about this. This is quantity. This is items, okay? Items sold, number sold. And this is dollars. So when I think about the slope on this graph, on the F graph, I have a change in the number sold over change in price. My slope is a change in the number sold over a change in price. When I see f prime of 10 as this, it's really that. I'm going to sell 29,000 fewer when the price goes up $1. And so what I can say here is, if the price is $10, then every $1 increase in price, that's this part on the bottom, because I have that positive 1 down there, every $1 increase in price will lead to selling 29,000 fewer items. Now, of course, this is only at 10, and if the price were 11, we might have a different f prime of 11, and we might say something different there. But at 10, this is the way I understand things. If I increase the price $1 more, I'm going to be selling 29,000 fewer of these things. That's what that minus 29,000 means. Okay? Okay, next. How about problem 16? So problem 16 comes with this graph, and it comes with some marks here, x sub 1, here, x sub 2, here, x sub 3, here, x sub 4, here, x sub 5, and over here, x sub 6. Okay. And this is a graph of, it's a graph of f prime. So there's my f prime graph. Whee! Okay. They ask me, when is f the greatest? And so people look at this graph and they say, well, f is greatest here. And then they remember that this is not a graph of f, this is a graph of f prime. And they say, Mr. Kukla, how am I supposed to know where f is greatest on this f prime graph? Well, let's understand this f prime graph. Here's what I notice about this f prime graph. This f prime graph never crosses the x-axis. This f prime graph is therefore always positive. And if f prime is always positive, what does that tell you about f? That's right, f is always increasing. F is increasing, 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 because f prime is always above the x-axis. So if I want to know, something like that, well, if I want to know where f prime is, if f is greatest, it's going to be over here. It's going to be at the far right side, there, at x6, x sub 6, f is greatest. Because this function f kept increasing, increasing, increasing until we got to that point. Actually, past that point, but this was the last point we could name. So where is f least? Well, f has to be the least over here, because this function was increasing, increasing, increasing. So over here, our first point, x sub 1, that's where f is least. Okay? All right. Next. That was part B. That was part A. C. Where is f prime greatest? Well, this is an f prime graph, and that's the highest y value named at one of these points. So f prime is greatest at x sub 3. And f prime least, where's the lowest point? C, D, f prime the least is going to be the lowest y value. And that appears to be, this one appears to be lower than that at x sub 2. E, we want to know where is f double prime greatest. Well, f double prime represents the derivatives, or slopes, of f prime. If I want to think about f double prime being greatest here, I'm looking for the greatest slope here. And it looks to me like the greatest slope here is at x sub 6. F double prime greatest when the slopes of f prime are greatest, and that happens at x sub 6. And f double prime least? Well, I want to know when the slopes of f prime are most negative, here or here. And when I look at the picture on the worksheet, this definitely looks more negative than that one does. So we're going to say for f double prime least at x equal at x sub 1. Okay? 17. Oh, there's a picture. Let's take a look at that picture. We've got goes up, comes down, has a flat, comes down, and back up. This is A. This is B. This is C. It's also our y-intercept. This is D. This is E. And here is F. Okay. Part A. Find the places where f prime and f double prime are non-zero and of the same sign. So as soon as I read that question, I say, yeah, I'm going to go to the graphic organizer. F prime, do we need f here? Oh, yes, we do. We need f, we need f prime, we need f double prime. At A, at B, at C, at D, at E, and at F. So, where's my y-axis? Oh, I got to bounce there. There we go. Okay, so f of A is 0. Slope is 0. F double prime on concave up is plus. F of B is positive. C is positive. D is positive. E is positive. F is negative. F prime. So on 0 slope here, positive slope here, 0 slope here, 0 slope here, negative slope here, negative slope here. F double prime, I'm thinking about concavity. Concave up, here, concave down, here, I have a change in concavity. E, concave down at E, yeah, concave down at E. I don't think it's an inflection point. And F is concave up. Okay, so what were we looking for here? F prime and F double prime have the same sign and aren't both 0. Same sign? Both 0, no good. So only at point B. 17A is point B. Point B is a place where F prime and F double prime have the same SIGN and are not both 0. What about 17B? At least 2 of F prime, and F double prime equal 0. Well, that happens here, and that happens here. So 17B, I'm going to have A and D. And really, I find it so much easier to take that information from here instead of trying to hold all those thoughts in my head looking at this. Really, really, really. It just, wow, I must have spent a decade doing this without the graphic organizer. It is so much harder than just filling in the graphic organizer. So please, fill in that graphic organizer. You'll be so much happier that you did. Ooh, a second problem, number 18. The distance of a car from its initial position t minutes after setting out is given by, so t equals 5t squared plus 3. So this is position, this is time. In kilometers. What is the car's velocity and acceleration at time t? Give units. So I'm plugging in minutes, and I'm getting out meters. So I know that S prime, which is V, is going to have units of meters per minute. How do I know that? Because the derivative is a change in position over a change in time. So change in position meters over a change in time minutes. And what is that v of t function? Well, I just have to take the derivative of this, and I get 10t. And the units will be meters per minute. We're also asked to find acceleration, which is the derivative of velocity. That's just going to be 10. But what about the units? Well, acceleration is a change in velocity over a change in time. So this was meters per minute over minutes. And I understand that some of you like to say the nifty cool meters per minute squared, and I don't like that anymore. I used to be fine with that. In fact, when I was a little kid, I thought that was so cool to say meters per minute squared, because I had no freaking idea what minutes squared were. And you know what? I still don't. I don't know what it means when you say minutes squared. Can you draw me that? Can you take me there? I don't know what that is. But here, I understand a change in velocity with respect to a change in time. That's how I understand it. And so I'm happy for this answer, but this is the one that actually makes sense in my brain. I'm changing velocity with respect to time. This? No, I'm sorry. What is that? Yeah. Okay, what's next? 25. Continuous function defined for all x has the following properties. F is increasing and concave down. F of 5 equals 2. And here we go. This is 5. And the ordered pair here is 5, 2. And since f is increasing and concave down, they then say f prime of 5. So the slope here is 1/2. Okay? And then they say, sketch a possible graph. Okay, there's part A. Part B, how many zeros does this have? Well, because this function is always increasing, and the y value here is 2, I can have at most one x-intercept, somewhere to the left of x equals 5. Okay, next thing. How many zeros does this function have? Oh, that's the one we just did, b. b said 1, 0, for x less than 5. Somewhere over here there's going to be an x-intercept. And then we say, what can you say about the location of the zeros? There we go, to the left of 5. And then they say, is it possible for f prime of 1 to be 1/4? Well, 1 is going to be over here. The slope here is 1/2. And look at these slopes. Is this slope steeper than this slope? I think so. I think the slopes over here are bigger slope numbers than the slope here. And certainly over here, the slopes are less positive than they were at that point. So I could believe over here a slope of 1/4, but not over here. The slopes are steeper than 1/2 over here. And therefore, no, it's not possible for f prime of 1 to be equal to 1. Is it possible? Wait. Sorry, I read the wrong problem. This is f I've been talking about. F. Is it possible? Yeah. Is it possible for f prime of 1 to be 1/4? No. These slopes are steeper than here. So that's not possible. But is it possible for f prime of 1 to be 1? Sure. This slope is more positive than the slope here, which is 1/2. So if this is 1/2, this is a number bigger than 1/2. Sure, it could be that. So E is yes, that is possible. And for D, which I completely missed, the limit as x heads to negative infinity of f. Well, this function is always increasing. So as I head that way, I must be always decreasing. So I'm going to go with negative infinity there. All right, only 2 more on this worksheet. What do we have? IBM Peru uses second derivatives to assess its relative success of various advertising campaigns. They assume all campaigns will produce some increase in sales. If a graph of sales against time shows a positive second derivative during a new advertising campaign, well, that's great, because look, our revenue is just going up faster and faster and faster. That makes us so happy to see that curve, positive second derivative. So yeah, no, we want more of that. Let's sell more of those things. A negative second derivative, right? Because it said here that the sales will always increase with a new campaign. So both of these, f prime has to be greater than 0. F has to be increasing. But in one of those situations, f is increasing at an increasing rate, and in one of those situations, f is increasing at a decreasing rate. And both of these have sales are going up, but it's this situation that, yeah, I want more of that. And it's this one where you say, well, maybe it's time for us to find another advertising company, because while sales increased, they increased slower and slower and slower. But here, ooh, thank you, Apple, sales increase faster and faster and faster. So IBM Peru says, yeah, get me some of that f prime greater than 0 and f double prime greater than 0. Because not only is the revenue going up, but the revenue is going up faster and faster. And that's fabulous. I actually heard that Walmart thought about this curve. And they said, you know what? When it gets here, don't order any more. Sell what you have and don't buy any more to sell. Because at this moment, your revenue is going up as fast as it can, and your sales are going to top out soon after. Sales are still going up, but really you're just selling off the rest of what you've got. And that's one of the reasons why Sam Walton has made a lot of money, because he is happy to use calculus here. Okay? All right. Last problem is over here on the side of the page. We're given this graph there. That's D, that's C, that's B, and that's A. And again, we have the table, except they've rotated the table sideways. So this is F, F prime, and F double prime. And we've got A, B, C, and D. So at this point, F is 0, F is positive, F is positive, F is negative. Well, no, what the goodness me. Sorry, so used to doing the chart with the other orientation that I completely ignored what I was doing. Okay, here, positive, positive, negative, because those are F values. Slopes at those points. I have a 0 slope there, I have a 0 slope there, I have a negative slope there, I have a positive slope there. F double prime, I'm definitely concave up at A, I'm concave down at B, I'm concave down still at C, I believe. I don't think that's an inflection point. Yeah, no, I don't think that's an inflection point. And at D, I'm concave up. Okay, so yeah, be comfortable with this. All right, well, there was 63 homework. I hope that that was helpful. Really, you need to really, oh, there's so many things in chapter 5 that you need to be really comfortable with. And you know, I would say if you're not, you need to be asking a lot more questions. You need to be taking a lot more notes. You need to be owning this stuff. All right, see you in the next